This is Jim Kunkel, and welcome to another edition of Thursdays with Tolga. Today's topic is corrosion basics. Coming to us from Turkey, Tolga Diraz is a protective coating specialist. He's also an instructor for NACE International and SSPC. Make sure that you register for the upcoming SSPC Gulf Coast chapters, current economic state of the oil and gas industry, plus the impact of COVID-19 panel discussion. I'll be the moderator. You can register with the link in the video description. I'm Jim Kunkel, and welcome to another episode of Thursdays with Tolga. Many of you reached out to me last week and asked, what happened? There was a Thursday, there was no Tolga. Well, we took a little bit of a holiday or a vacation, depending on what part of the world you're from. But we're back. And back with me is Tolga. Welcome, Tolga.
Welcome, Jim.
Hey, how was your past week?
It was fabulous. It was really amazing. I enjoyed much with my family. I hope all our audiences are enjoying the summer with their loved ones.
Especially with everything that's going on in the world today, it is good to be able to take time and spend time with your family, and also to kind of catch up with the other parts of the reality that we live in. But it's good to have you back on this Thursday. So, Tolga,
Right.
what are we going to talk about this Thursday?
Today we are going to talk about a very fundamental, very simple but very important subject. We will talk about corrosion, but the basics, just the basics and the fundamentals.
Perfect.
I mean, excuse me about my English accent, but you can always, my audiences can always think that I'm a Turkish, not a U.S. citizen, so my English sometimes be a little bit funny.
Oh, I think your English is better than mine.
Okay, thank you very much. Thank you very much, Jim.
So, hey, Tolga, let's go ahead and we'll open this up. And so the first question I would have for you for our discussion, what is corrosion? Why is it important for us to really tackle corrosion in the world today?
Jim, let me look at this from a global perspective. We have 5 continents, and in 5 continents, there are corrosion societies. And then we will come to that point. But let's talk about societies and their corrosion definitions. Firstly, we'll talk about from Australia, the Australasian Corrosion Association. They say that the corrosion is the destruction or deterioration of a material because of reaction with its environment, and the term can refer to a process or the damage caused by such a process. And we move on to Europe. And there is the EFC, European Federation of Corrosion, with very big and one of the major societies in the world. And they say that the corrosion, the definition, their formal definition of corrosion in their website is: this corrosion is an irreversible interfacial reaction of a material with its environment, which results in consumption or dissolution, often resulting in effects detrimental to the usage of material. And right now, and we are coming to the United States, your country, and a NACE and SSPC is hot topic. They are beginning to merge. So the NACE, the National Association of Corrosion Engineers, is saying that corrosion is a naturally occurring phenomenon, commonly defined as the deterioration of a material, usually a metal, that results from a chemical or electrochemical reaction with its environment. And we will come to chemical and electrochemical, what it means, later on in this episode, Jim. And finally, SSPC has a similar definition. Corrosion, but a little bit simple, is a loss of mass caused by metals' natural reaction to the atmosphere around it. So basically, what is corrosion? If I say it is the natural process that the nature takes what it gives, what we give to the metals, because we are giving what we are giving to the metals a lot of energy to produce or to purify metals, to produce metal articles, metal items. So this energy is becoming disoriented, or this energy from time, it becomes disoriented and consumed, and corrosion is this result of this process, which is basically, it's a Latin word. It comes from corrodere, and it is basically say it's gnawing into pieces. So you see the dog gnawing the bone. Is the corrosion is a very gradual, very small gnawing of pieces of metals, most of metals, but later we will come other materials other than metals like ceramics, glass, or composites, or may also be corroded in corrosion, in terms of corrosion. And most of the time, maybe you are also facing, I come with the industry, corrosion and rust becomes synonymly defined, or they are pronounced, but it is wrong. Rust is a color, Jim. Corrosion is a process. Rust is a color, and it comes from Rasta. It's a Proto-Germanic origin, and its Lithuanian origin is brownish. So it means a brownish or a red color, rust. So please be careful about that. All audiences should be careful about that. Corrosion is a process where rust is the result. So sometimes if the metal is not a steel, because the steel has a corrosion product, the rust, but if it is a copper, it is the corrosion product is patina. We call it patina. So corrosion and rust is not the same, but corrosion definitely covers rust. So it's a bit, this process is the bigger set of the rust. So let me see in philosophy what it means. Why do we call corrosion, and what does it mean in simple terms or in visually? So you see the this ball, Jim. This is let me say this is an ore. This is the unprocessed metal. Unprocessed metal as an ore. So we as human give energy, and that in that way this ore becomes the pure metal. But the natural forces of the nature takes this energy, because this is a high energy level and it is not stable. It becomes destabilized by producing a rust or corrosion products, whatever it is, as a metal, and becomes a stable product. And believe me, the corrosion product and the ore composition is the same. Mostly, there are a lot of iron oxides, but mostly as ore of steel or iron, there are two ores, magnetite ores, and the metallurgist knows that very well. The hematite and magnetite, F3O4 or F2O3, and these are also the major constituent of rust. So basically, everything is in a cycle. Everything steel industry can be said as a sustainable industry. So this is the corrosion cell in very simple as an animation. You see there is four elements as a corrosion cell. What are they? There is one anode. Because the anode is the, as you can see from the animation, is the corroded side that the metal ions are given to the solution, and the cathode is the reduction side that the ions are gathered, and there is the metallic pathway that the ions can move on it, and there is an electrolyte which is a conductive media between the anode, cathode, and metallic pathway, so that these four members of corrosion cell constitute of a corrosion. And what it means for corrosion is also is an important subject for engineering type. So because there is corrosion and corrosion science, there is corrosion engineering. What it means is scientific, that corrosion engineering is the scientific, technical, requiring technical, scientific, and engineering skills and knowledge of natural laws and physical resources to design, implement materials, structures, devices, systems, and procedures, and manage. So what engineers do, also they can make life predictions of metals, steel, and take proactive actions. How? Using these knowledge, corrosion science knowledge, and the skills above, scientific, technical, engineering, and with the use of digital tools, with a digital age, since we are in the digital age, like advanced corrosion inspection, monitoring, testing equipments, ultrasonic, magnetic particle techniques, dry penetration inspection, electroresistance probes, electrochemical corrosion testing equipments. With that, we will not be going into detail, but you name it, a lot of digital tools that the engineer. So it's a very detailed, very comprehensive subject. Corrosion engineering is. So in layman's term, Jim, we can say that corrosion engineering is the application of principles evolved from the corrosion science to minimize, prevent, or corrosion control. And why it's important? This is the second part of the question, I think. Am I right?
Yes.
Okay. Basically, four of them. Probably most of us knows that these four, the aesthetic laws, economic laws, material damage, and corrosion. But we will be just touching very slightly what aesthetic laws means. Aesthetic laws means rust spots, because you know when it's corrosion takes place, there is rust and rust spots and makes the surface very ugly. And if there is no rust, but perhaps there is another area that is rusting, and the rust stains may be bleeding into the painted area. And there is, although you cannot see the dust, rust, or corrosion, there is discolorization. Have you ever seen in your water, in your fountain, that the city water is all discolored because of the rust in the United States? Because in Turkey there are sometimes.
Same thing here.
And same here. And because of that, the city municipalities changed the pipelines, the infrastructure. And industrial plants, equipment, machines get rusted. And even our houses, apartments, flats get rusted. So corrosion basically is everywhere, and it affects it aesthetically because it makes the places, it makes the surfaces seemed ugly, and makes the buildings, especially prestige, lost. And secondly, and more importantly, James, can you believe that in a year, $2.5 trillion is being lost because of the corrosion? And this is in a national scale. For every country, it is between 3 to 5%. So every country is losing right now 3 to 5% of their GNP, their gross national product, gross national profit. Sorry, am I right? GNP. Anyway, affects all sectors, but mostly agriculture and industry. And this studies, especially NACE, has a really nice website. They have a website, and they have an initiative called Impact. Do you know Impact? By the way, have you ever heard of Impact, Jim?
Actually, I've read the report, and in my current duties with SSPC, I utilize that Impact Plus report extensively. And in that report, you are right, it's a very detailed report
And there is the link here, and you can also include in the video description if you want, Jim.
I will.
And just the one paragraph I would like to stress that industry-based improvement have been observed. I mean, not every industry is losing money, but some of the industries, like automotive industry, is losing money, but it's getting it's getting less and less. So automotive industry knows the corrosion problem very well, and they are trying to improve themselves. So in 1975, think about your first car, how it is getting rusted so quickly, but it's now the cars and the automobiles in right now, we don't have corrosion so much because they are getting improved. And when we come to industrial, since we are in the industry, and it is most of the time replacement of, it makes, what the corrosion makes, replacement makes requires the replacement of corroded equipments. And because of the corrosion, there is a tendency to over-design to allow for corrosion. If there is corrosion, there is a contamination, especially in the marine industry, in the marine and container industry, there is a contamination of product. There is a loss of efficiency. If there is corrosion, there is probably a loss of efficiency in the industry. There is a loss of valuable, because there is corrosion, there is prestige loss, and there is other things. So there is a loss of valuable product. There may be a shutdown of equipment. We will see that in a moment. And most of important is what affects our life is damage of equipment adjacent to what corrosion fail, and depletion of natural resources, like including metals, the fuels. And we are coming to the end. Health issues, for example, the pollution due to escaping product from corroding equipment due to corrosion product itself. And maybe most important, the most important is the safety, James. This is the accidents, unfortunate and catastrophic accidents that we will be dealing right now. What are the accidents? Very dramatic accidents in the history because of corrosion. The first one, probably everyone, the corrosion industry knows about, is Aloha Airlines. This airline is, this aircraft has been torn apart the upper side during the flight, and luckily the pilot makes the flight, the airplane land off, but there is a one passenger died, unfortunately. But this is a very serious. This was very serious. Because of that, the airline's rules has been changed and airline manufacturing has been changed. And second is the Mexico incident, severe, because of there is some small, very small corrosion issues in the severe underground severe infrastructure in Mexico City. There was a severe explosion in Mexico, and I will say right in a minute in which year. The year was 1975, I think. It's a little bit. And right now in the United States, most of them has been solved, but in the aerospace industry, the corrosion is a big issue, especially for the aircrafts. And do you know that some time ago, some F-16 aircraft jets have been crashed because of corrosion? 7 or 8 aircraft jets. So there are a lot of corrosion related issues in when you go to USFEAF website about corrosion of aircrafts. And one of the biggest accident in the world history is the Bhopal disaster in India. This accident in 1974, it is over 50. There is the gas industry. It does gas. I don't want to give the company name, but the one global big company, but they can search in the internet. But in this company, because of the corrosion, there is a gas leakage, and the methyl isocyanate is a very, very hazardous, very toxic gas, was made its way into the air, and the small towns around the plants have been intoxicated, and it's estimated that over 500,000 people have been intoxicated or have been injured because of that, and nearly 6,000 people become dead because of this disaster, this corrosion disaster, this explosion, corrosion-related explosion disaster. And another one is the marine industry, affects marine industry, the sinking of the tanker Erika. Because of this Erika tanker sinking, the marine industry manufacturing techniques have been changed, because since that time it was single hull, and right now in the marine industry people know that especially tankers are not single hull, double hulls, so they make it a little bit more corrosion resistant, and the fuel oil and other contaminants inside are right now they are not contained in the one hull, but they have it in two contained hulls, so double hull things. So this is also a very tragic incident in the world history. And you know that in the United States, we have talked before, in the multi-code, single-code instance, the federal agencies, transport agencies also have issues about bridge coatings, bridge engine. And I think you have a very nice prepared bridge coating thing last week. Am I right?
Yes, talked to Tony Sardanis from Gannett Fleming regarding bridge coating programs. Mm-hmm.
Yeah, Tony Sardanis. So maybe you can also include in the video description. I watched it, and it's a very nice, very nicely prepared episode about bridge coatings. So about which is related with bridge corrosion. So there is a nice video, but would you like me to show it, or would you like me to make this audio to see this later about corrosion?
I think what I'll do is do a link to it in the description, so we can continue on.
Okay, NACE has a spotlight on corrosion. They are airing. Maybe I don't know right now they are airing or not, but it has been prepared with PBS, the channel PBS. So very nice. I strongly recommend our audiences to watch this corrosion spotlight on NACE website and in your link.
Perfect.
Anyway, and lastly, corrosion, because of all the things we have talked so far, big industries, oil and gas, offshore, do set up corrosion management programs in their facility. For example, this is a picture that I taken from Bechtel. You know the Bechtel company from United States. They have a really nice, and also I would like to send my gratitude to Mr. Benjamin Fultz. He's a great NACE corrosion engineer. I really admire him. Do you know him, by the way, Jim?
Yes, I do. He also was a past president of SSPC and also on the board of governors of SSPC. He's, I believe, now retired, but he's still working in the industry.
Yes, I believe he has prepared this checklist, corrosion management program flowchart. So anyway, so basically what this flowchart includes is the identification of corrosion threats, life cycle cost analysis, corrosion control strategies, corrosion monitoring and inspection step, and program performance review and management. This is all, but it's in more detail, by the way. So this is all about basically a very brief summary of corrosion, why it's important to us, and what is corrosion, by the way. Would you like to add something more, Jim?
Well, the only things that I would add to it is that for everyone, listening to this program, is that corrosion is a natural process, and you're looking at iron and steel. You're looking at that type, those metals. They want to go back to their original state. Um, that when you have section loss, or let's say metal loss from corrosion, it's not that it disappears. It's just been converted. And what Tolga pointed out here too is that we have to have a constant battle with the forces of nature that are, again, the nature of that metal to go back into its natural state, as we have to find a way to balance it so that it doesn't want to convert. And then the only ways to really look at that is through corrosion mitigation, management. Also, too, when you're looking at things such as cathodic protection, and then a lot that Tolga and I focus on is the protective coatings and lining side. So Tolga, very good overview of that. And I believe what probably would like to know more about are the main types of corrosion, that are frequently encountered in our daily and in the various industries worldwide.
James, you're right. There are many main types of corrosion, but we will be just covering very briefly, because if we want to just concentrate, focus on, we cannot finish this episode. So I will be very briefly. I'm sorry about that. And what are that? I will be very briefly making it in the three classes. The one is macro. What is my macro, which we can see. What are the micro types of corrosion in macro? Is uniform general corrosion that we all know. The crevice corrosion about in the crevices and there are mechanisms, but I don't want to go into detail. There is galvanic corrosion about between two dissimilar, at least two dissimilar, sometimes three dissimilar, more than two dissimilar galvanic corrosion. There is pitting corrosion, especially in stainless steel, aluminum, or some very special metals. There is underfilm or film-form corrosion. There is selective or dealloying. These can be seen by the naked eye, but some of them we cannot see it. We try hard as hard as we can, but we cannot see it. We can see it by microscope. What are they? The intergranular corrosion in the very granules, the boundaries of granules corrosion. There is stress corrosion cracking. There is corrosion fatigue, especially in the aerospace. And these are main types, but there are some that can be seen by macro, or that can be seen by naked eye, or sometimes with the use of microscope. This erosion corrosion, which is not easy, especially there is two forces. There is erosion, there is corrosion. There is cavitation, especially high velocity flowing pipes. And if there is a high flow of liquids, gas, there is a cavitation corrosion. There is fretting corrosion if there is two surfaces moving next to each other. And there is microbiology induced corrosion, which is sometimes microbes, as we talk about the microbial, antimicrobial coatings. Sometimes microbes do create corrosion. It's very interesting. There is no oxygen, but microbes do create corrosion. But we will not be going into detail. These are main corrosion types. James, would you like to add something to that, or did I miss anything?
No, I think you a very comprehensive list, and to your point, we could spend literally a whole 24 hours talking about subset of this. So maybe that's an opportunity for us moving forward.
There's also an ACE class for that. There's an ACE class, corrosion ACE classes. That
exactly. Yeah. Maybe for future opportunities and discussions, we could really kind of drill down on some of these, the ones that are more commonly. Let's say the ones that are more commonly known or, stressed over in the different industries. But go ahead and continue on, Tolga. Very good.
Okay. And why? Okay. We are all in the industry. We are industrial professionals. And why it's important? Because in industry, they make a lot of money. The corrosion makes. So what are the industries that is very, very important in terms of the damage because of the damage of corrosion gives? First of all, I can say that the automotive, as I told you. And actually, I have a very funny story about my first car, actually my family's first car. I drove it on the sea, but it was a dry sea. It was a sea in the in the coast of Mediterranean. So I recommend people, or I challenge our audiences to drive their cars near the seaside. I bet they have a corrosion in their car as soon as they get to their homes. Because if there is salt, especially ocean salt or sea salt, the corrosion attacks. So it's very, my first, if I was in the university, I didn't know that corrosion was there, but I learned it from the hard way, James, the corrosion.
That's
so
not
if you drove your...
I was going to say that's not your car there, is it? After one day?
No, my family's car. I literally make my family's car corroded away. By driving, by trying to learn the car, in the seaside of Mediterranean. So when the mechanics say that, my dad, what happened to your car? Why it's so corroded? Because my son has driven in the seaside, very in the shore of the seaside. So anyway, James, and the second one is as we talk, the infrastructure, structural steel, the bridges, the railways, whatever you name it. If there's a structural steel, there is corrosion. And the third one, as we know all, that the offshore industry. By the way, in Turkey, we have recently found natural gas in Black Sea, and we are also exploring in the Mediterranean Sea. But you know that? Maybe you have heard about it. Anyway, if there is a petroleum or natural gas, there is offshore, And in the offshore industry, they are experiencing a lot corrosion in the corrosion. Because of that, there are specialized coatings and paints for the corrosion industry, offshore industry. And lastly, the nuclear industry. Unfortunately, Turkey is just about to enter nuclear industry with Russians. But I know from the United States, my experiences in SSPC and NACE conferences, that in each conference, there is a special session, special day, maybe half day, full day, about the corrosion the importance of corrosion in the nuclear industry, because the radioactivity and all the heat, radioactivity makes a lot of corrosion. And it's a very unfortunate, it's very critical places, the nuclear industry, because if there is a corrosion, it is not failing, it's failing, but the radioactivity also is exposing to the area. So it's very important. It's very much more important than the economy. It's a health issue.
Yes.
Yes.
Very good.
And would you like to add anything about industrial corrosion?
No, other than, every industry has to have a different type of strategy and kind of covering it. And to your point, I'm 54 years old, and, the older cars, they would, start to rust out in 5 or 6 years because of, the environmental conditions and things like that. Today, the cars do seem to last a lot longer, which is great and everything like that.
Yes, they are getting more different alloys, different coatings, so they are getting improved.
Exactly. So, the industries have to be able to adjust to it. But you also have a lot of other things that, to your point, were critical industries that can have failures. The bridge and highway market is one. The nuclear industry is one. Offshore, if you have corrosion and you have on a production rig and you have a failure happen, you could have an oil spill of catastrophic size. And so you want to make sure that, again, like I say, you have a corrosion mitigation, you have a corrosion management and a plan to be able to tackle that. So, you know,
and NACE and SSPC has a great role in reducing, because improving the awareness in these industries, especially structural steel, offshore, and nuclear. I recommend everyone to attend any NACE or SSPC conferences in the future.
Sure.
There are great people and great opportunities to learn more about the corrosion in structural steel, offshore, and nuclear in the SSPC and NACE conferences.
I agree completely with you on that. So, you know, a lot of people do ask the question, you know, is it technically possible to prevent or control corrosion? You know, so what are some of the most used corrosion control prevention methods in the global industry?
James, definitely there are methods, and there are 4 methods, actually 5 methods. There is material science, there is design and engineering criteria, and design engineering and considerations, protective coatings and paints that we discussed before, inhibitors, and cathodic and anodic protection. There are mainly 5 of them. There may be more, but there are just mainly 5 in all the books, and in all the organizations focus on 5 different methods or techniques of corrosion control or prevention. So let me summarize briefly what material selection and shading. Material selection is basically we talk about most of the time corrosion of metals. And what we talk about is steel, like carbon steel, galvanized, stainless steel alloys, cast irons, coppers and alloys, aluminiums, and high performance alloys like nickel and cobalt. All these metals should be protected and can be used for also corrosion protection. For example, we will come to that. For example, steel can be protected with galvanizing, or aluminum can be protected with the protective coatings. So steel is a substrate, but can be also used for protection, or aluminum, like that. So the polymers. So the first is very important because it makes the substrate. So these are the substrates of which we will be protecting from corrosion. And then comes the polymers, as a substrate. What are the polymers that are used for the construction industry or industrial uses, like polyethylene, polypropylene, polyester, plastics, rubbers? So these should be also protected. And the ceramics, alumina, zirconium, chrome monoxide, tungsten carbide, this should be also can be used as a corrosion resistant or corrosion resistant material. And the composites. So these are all the alternatives that can be selected because that we can select from the material selection pool. This is a pool. And the parameters of selection is, what are the corrosion resistance of these materials? What are technical properties, like mechanical, chemical? Is it suitable for our project as a mechanical, chemical? What are the fabricability? For example, aluminum is better in corrosion resistance, but steel is more fabricable or more easy to fabricate. And what are the availability in your country? For example, maybe in some countries you can find steel much more readily, but in some countries you cannot find aluminum so easily. So available. And lastly is the cost. Sometimes you need to understand there is a budget for the project. So if the project is a limited budget, you need to go for an economic material selection. And the second is design. So we select the material, proper selection. What we mean by design? So trapped water. If the water is trapped, we should prevent it in order to prevent the corrosion. So drainage is important. What are the welding and bolting issues? What are the gaps? What are the galvanic coupling of materials? Excess, we should require some excess for maintenance, for the future maintenance, because the material will be aged, and we should give excess in the design phase, is design stage, the excess for maintenance. So in the design stage, we should give excess for coding application. And what are the transportation erection issues? So all these should be assessed before the project begins in the design stage. And there is a nice standard which is covering all these items, is ISO 12944 part 3. And this is getting also very revised last year or 2 years ago. So I recommend people to look for it. And after the design, there is protective paints and coatings that we will not be going to. So we are both protective coating specialists. But as you know, there are endless variety of protective paints and coatings. So I'm just keeping it simple, like mentioning the main types of protective paints and coatings, like alkyds, the good old alkyds, acrylics, the epoxy paints and coatings, polyureas, polyaspartics, polysiloxanes. It should be polyaspartics. I'm sorry, it's misspelled. Silicones, zinc-rich coatings, powder coatings, hot dip galvanizing as a different coating, thermal spray metallizing that we discussed earlier last week, and etc. So a lot of things, but we cannot give into detail. And these are the protective paints that we can select, but this is also another episode that we should be covering maybe in the future. Maybe you have also doing, a lot of people are talking about this also. There are a lot of specialists in alkyds, polyureas, acrylics. So there is inhibitors. What are my inhibitors? They are chemical compounds added in small concentrations, like thousands, 1 to 1,000, 1 to a million ppm requirement. So they are added in very, very small concentrations, but it gives very temporary protection. The reduces of corrosion rate of a metal, mostly metal, exposed to environment. Inhibition is used internally with carbon steel pipes and vessels as an economic corrosion and control alternative. It's more economical, but the corrosion prevention or corrosion control is limited in months to years, not for decades. Just maybe 1 year, maybe 6 months, maybe 12 months. And the major industries using corrosion inhibitors are oil and gas exploration production, heavy manufacturing, tank ships, water treatment, fuel industry. For example, in your fuel, there is corrosion inhibitors. Maybe you know that. So in every part of the most of oil and gas and petroleum chemical, there are also different kinds of inhibitors. So what is making it? In simple terms, they make a passivation layer which prevents the excess of the corrosive substance to the material. So they cover it, and the oxygen and the other corrosive metals corrosion ions cannot reach to the metal, to the substrate. And lastly, there is cathodic and anodic protection, which is an electrochemical corrosion protection, which I mean using electric and chemicals together. What I mean by that, mainly we are using electrics. There are two types of electrochemical corrosion control, cathodic protection. One is galvanic, which is you attach a different metal, making a galvanic corrosion actually. For example, zinc, steel, aluminum steel, and dedicate one metal to corrode. So you sacrifice it, metal, and the steel become protected, but the other metal becomes corroded, and you see that over time the metal becomes very corroded and becomes fade away. And there is also a more economical, but the high there is a initial investment, high initial investment scenario or alternative is a impressed current cathodic protection, whereby you give a small amounts of electric current or voltage to the steel that you want to protect, and you make, in a way, you make the steel as a battery. So the steel is protected, and there is also another anode, which is a titanium, most of the time titanium. But I'm not a cathodic protection, by the way, specialist. So maybe cathodic protection specialist knows better than me. So I won't go into detail. So these are the 5 different cathodic these are the 5 different what can I say? And just a minute. These are the 5 different protection, corrosion protection methods that we have discovered.
Very good, very good.
So, what would you like to add? Anything more? So, I am a little bit.
No, I think you've done a very great job in doing that overview, and to your point, I think in addition to the other topics that we kind of had to glaze over real quickly, these topics can be really broken down into single episodes to talk about these as well. And again, that might be something that we might want to consider too in future discussions. So Tolga, in the interest of time and moving on, in the world today, there's a lot of different organizations that represent different industries and different types of challenges that we have on the earth today. Obviously, corrosion is a really, really big, costly, damaging, and also concern for a lot of people. What organizations are focused on dealing with corrosion and the prevention of corrosion?
Jim, frankly speaking, I have learned a lot about with the global organizations around the world, and I would like to share with our audiences. And as we have shared in the beginning with the corrosion definitions, there is one very big, large organization called Australasian Corrosion Association, called seen in shortly ACA, in Australia and in New Zealand. I recommend, I urge people today to go and search for the website. There's of information about corrosion, and they have also they have a YouTube channel, and they have, and also I also have the opportunity to meet some of the corrosion specialists from ACA, and they are very nice and very knowledgeable, very wise people. So moving on to Europe, there is EFC, as we talk, European Federation and Corrosion. This is an umbrella covering all the national corrosion association. For example, in Poland, in Turkey, in Germany, in France, in UK, there are different corrosion federation organizations, institutes, or associations. But this is an umbrella covering all the national organizations. So if you go, or if our audiences go to the website, they can see all the corrosion associations in Europe by visiting their website. Moving on to United States and Canada, I think the NACE International, which is the greatest one about. I believe so, because they are the first. I believe they are the first in the United States, in the worldwide, and they have an extensive archive, and they have very nice and knowledgeable people, which you also know in years. I believe so. And there is ICC, International Corrosion Council, which is also an umbrella covering all the ACA, EFC, NACE. And there is the World Corrosion Association, which is also an umbrella organization, which covers the ICC, ACA, EFC, and NACE. So WCO is like the biggest umbrella of covering. Sometimes they are meeting in different countries, in different continents. Some representative from NACE and EFC and ACF in the WCO events or conferences worldwide. So these are 5 organizations, but there are much more than that. But these are the main biggest organizations in the world today, Jim.
Very good. Very
Would you
good.
like to add something? I mean, did I miss anything, Jim?
No, very comprehensive.
Based on your experience.
Yeah, very comprehensive, and I'll list a couple links to some of those organizations that you did mention, so people could check them out.
Yes.
So and we've had a really great discussion here, Tolga, regarding let's say the basics of corrosion.
Excuse me, Jim.
Good.
Jim.
Yes.
There is two resources I should mention. There is one ISO Technical Committee 156. Which I will give the link to you, and there is ASTM Committee G01. They have also lots of standards and guidelines about. They are not organizations solely on corrosion, but they have extensive collection of standards in ISO and ASTM. So please go on, Jim.
Oh, perfect. Well, like I said, really, there's a lot in addition that we could talk about. This basic overview of corrosion or corrosion basics that we just had. In kind of closing out our Thursday here, is there anything that we didn't talk about that you'd want to cover with the viewers?
Yes, Jim. Actually, in closing thoughts, I would like to. By the way, my internet connection seems unstable. Do you see what is seen right now?
Yes.
Okay.
Yes.
So everything right now we talk here about corrosion is somewhat bad. It is bad for our life. It's bad for our health. But corrosion is not bad so much. Corrosion can be used as a good purposes, as a functional purposes due to their electrochemical process nature. What I mean by that, for example, the Statue of Liberty. Once it was copper, it was made from copper. So the copper changed the color from brown to green. So some metals can have a nice color change, or like copper. So the corrosion can be used as a color change if you want to make, for example, some item look like antique. So you can use this color change. So it's very nice. So for example, copper is going from the white or the light brown to yellow. And secondly is, probably most of us doesn't know that it can be used for electropolishing. What I mean by electropolishing, it's like the opposite of electro coating, which will be right now called, or opposite of cathodic protection. It can be used to clean the surfaces by the use of the electrochemical corrosion process. So you can use by giving some electric and placing an anode and cathode, make untreated metal cleaned by the use of this corrosion principles. And other thing, and more useful application is the electroplating application. You know that most of our cars, automobiles, or like in our furnitures, in our homes, most of small metal items are not painted, but they are electroplated with the use of electrochemical process, by using one metal corrode away and one metal gathering all the, like making one metal copper and metal steel. So it can be coated, copper as a steel coated with copper, or steel coated with chrome, chrome, or you name it. So, and the most important is, and I am very excited about that, this electro vehicles that we are using and we will be using will be based on the batteries and fuel cells. And all batteries and fuel cells are based on the corrosion principle, the electrochemical corrosion principle. So what is corrosion is right now, it's also happening in our batteries, in small batteries or in our electric cars like Teslas or other cars or fuel cells. In every car, there is corrosion, and the corrosion is utilized as a good purpose, not a bad purpose. So, James, to summarize up, there are a lot of parameters, but right now, since we don't want to spend so much of time to our audiences, and I don't want to give into detail like material selection, design. So this is just a basic overview of that. As I am giving this example in every episode, I love this quote. We take in generalities, but we live in detail, because we just give generalities, brief examples. But unfortunately, all the things have a lot of details that we cannot cover in this episode, James. Would you like to add anything, James, to this or to our episode?
Well, I'd say a great job, Tolga. You really covered the basics. That's really what we wanted to do, and I think we definitely achieved that. The other thing is, I think it does open up a lot of opportunity for us to talk further about corrosion and strategies related to either the mitigation of it, the management of it, and the protective through the use of coatings and linings to protect assets and structures and things like that. So very good job. I appreciate it.
I would like to give my sincere thanks to you, because I love my job, as you know, Jim. And corrosion science is very exciting business, and it will as we live in our lives, corrosion will be on our side, and corrosion engineering. We will be talking about corrosion engineering and corrosion in the future.
Exactly.
So if you have any questions, if one of our audiences have any questions, they can ask you or me, and I would be glad to answer them frankly.
Perfect. And for the viewers, I will have the website address to Tolga's nonprofit information website, also email address, as you can see here on the screen, to reach Tolga. Tolga, thank you for an awesome Thursday. Great to have you back again.
Thank you very much, Jim. I'm also very happy to be with you. And hope we can meet again soon.
Yes. Well, at least we can do it virtually. We can do it being me in the United States, you being in Turkey. We can do it over the through the internet.
Yes, you're right.
All right. Well, Tolga, have a great day.
Have a great day, Jim.
So, Joe, for the lay person who's watching this episode, who might only think that corrosion engineering